Okay, so we're going to go over compound interest. So we have a ton of information here, right? This is our compound interest formula. And these are all the four major variables. Okay, so we've kind of laid out what the four of them are. A is the amount in the future. P is the principal, so the amount of money you're going to invest right now. I is the interest rate after it's been compounded, and N is the number of periods. But I and N we have to also calculate for. I is the actual rate of interest per year divided by the compound period, and N is the number of years times the compound period. Okay, so that's how we build those two. So we're going to come up with an amount. How much money would you like to invest right now? Let's just make up any value that you can think of.
4,000.
4,000. So let's say we're going to invest $4,000 right now. Okay, and what percentage do you want it to be at? Let's come up with any percent here.
4.8, I guess. I don't know.
Okay, let's use a different one. Let's go 3.8 since you already did one like that. Okay, 3.8%. Now I've told you it's been compounded quarterly. Okay, so this is going to be compounded quarterly, so we're going to have to talk about that. And for how long do we want to invest for?
3 years.
3 years, that's great. Okay, so we built the question ourselves here. We have $4,000 at a generous interest rate of 3.8% compounded quarterly for 3 years. Okay, this 4,000 we've done in blue, which is essentially our principal. That's how much money we're going to put in right now. The 3.8% is technically the rate of interest right now, and then it's compounded quarterly. Quarterly means what number? How many times a year? 4. So in other words, our C value is going to be 4. Okay, so in order to build this interest rate compounded, we take our interest rate, which is our 3.8, and divide it by 4. Now, 3.8 has to be in a decimal form, so we'll have to convert that. And finally, the number of years is for 3, and the number of compound periods. Well, if it's 4 times a year times 3, the number of periods is going to be much larger than 4. Okay, so let's first do that. We'll figure out our interest rate compounded. That's going to be I is equal to, and how do I make 3.8 a decimal?
Oh, you move it 2 places.
Yeah, that's right. So we're going to get, if you move it 1, 2 to the right, it looks like that. 0.038. Okay? Divided by quarterly, we said was C, was 4. So we divided by 4. So let's see if we can bring out our calculator here. Okay, 0.038 divided by 4 equals 0.0095. Great. So our I in this question is 0.0095. Okay, that's our interest rate compounded quarterly. So what that means is you're getting 1/4 of that 3.8% every 3 months technically, but every quarter of a year. So if you multiply this by 4, it takes us back to the original interest rate, okay, of 3.8%. So 3 months in, we get 0.0095, so that's like 0.95%. And then another couple, 3 months later, we get another 0.95%, then another 0.95%, and another 0.95%. So we get that 4 times a year. Altogether, that adds up to 3.8% a year. That's the idea of compounding something over time. Okay. The other thing we have to figure out is the number of periods. Okay, our N. Well, N is years times compound period. So if it's for 3 years and our compound period is 4 times a year, how many total times does it compound over the life of this investment? 12. So 12 times we're going to earn interest over the course of 3 years. Okay, so we have all that information, so we can now kind of plug it into our equation. So I'm going to scroll down a bit, and I'm going to plug it in from memory here. We're trying to find what our future amount is, so we still don't know what A is. Our principal we said was going to be $4,000. Okay, so that was our P times 1, and that's right, times 1 plus I. We already calculated I. It's that value there, 0.0095 to the power of N. And N we already calculated to be 12. Okay, so does that make sense how we relate it to the formula?
Yeah.
Great. So now this is strictly bed mass simplifying things. So this is a really simple one because it's going to become 1.0095. So we get 4,000 times 1.0095 to the power of 12. Now because it's bed mass, we have to deal with the exponent first to this base, and then that'll give us a value that we're going to multiply by our 4,000 here. Okay, so we'll do this all kind of in one step. Luckily we have calculators, so I'll do this all in one step. my calculator, I can actually probably write it out in that order. I can write out 4,000 times, and my multiplication symbol, bracket 1.0095, bracket, and this means to the power of for me, to the power of 12, okay? Because my calculator should obey bad math, it should do this in the correct order. So here we go, 4,480 and 59, let's say 60 cents. So 4,480 and 60 cents. So that's how much money we'll have in the future, okay? Now, here's another question to go along with this. Let's say instead of an amount I want to invest, so our principal, we'll assume everything else is the same. Let's say I just decided, oh, well, in 3 years, I know I have this bank account that earns 3.8% interest. It compounds quarterly. 3 years from now, I want to have, oh, I don't know, $10,000. Okay. In other words, I'm giving a value for A. Okay, so this will be our part 2. Example 2. Okay. I want to have $10,000. Okay, so that's going to be our A value. How much do I need to invest now? Okay. How will we set this question up? Do you know what we'll do with this formula? I'm doing it on the right here. Remember, we normally write A in, so let's replace that. We know it's going to be 10,000, right, is equal to, and I'm thinking to myself, how much money do I have to put in now? So which variable am I kind of looking for?
The interest rate.
Well, the interest rate has been given to us, so I'm going to fill you in with all the other things, okay? Technically, we've already compounded the interest. It's a 3.8% interest rate, compounded quarterly, so we're keeping this number the same. Okay, so it's going to be 0.0095. And we're going to do it for 3 years, compounded quarterly, so I know it's going to be to the power of 12. What's the one thing I'm looking for in this case?
The principal.
Yes, so this is a little different. Okay, I'm trying to find the principal. So the idea is I would need to have this much money in 3 years. How much money do I have to put into the bank right now? Okay, so this is solving for a different variable. We can still follow BEDMAS for this. First, we'll put this number to the power of 12. Okay. So 1.0095 to the power of 12 is going to give us a pretty big one. 1.12 we'll say, approximately. So this is 10,000 is equal to, what do we say, 1.12?
Yeah.
Okay. The goal is to isolate for which variable?
P.
P. So how do I move 1.12 to the other side of the equation?
Oh, you have to get rid of the brackets.
Well, the brackets actually what they mean is P times this.
Okay.
So because it's multiplication, when I move it over, what operation will I need to use?
Division.
That's right. We need to divide when we get to the other side. So this will read 10,000 divided by 1.12 is equal to P. So our original principal, we'll divide these values and find out. 10,000 to 3 divided by, hit that number? Yeah, there you go. I took the number right from there. Is equal to 8,927 and 38 cents. 8,927. I kind of forgot. Is that the right number? 8,927.38. Okay, 0.38. So what does that mean? What is this amount telling me? What was my original question asking?
What the principal is.
Yeah, and I knew I wanted to get to what amount?
10,000.
So in 3 years, with this bank account, the one that gives me that percentage quarterly, I need to invest this much money to have $10,000 from 3 years from now. Okay, so that would be solving for principal. And the other one we solve for a future